Alright, welcome back, generals, to another Let's Fix Generals 0 how to make the best game. And last session we have pretty much copied the code here, and it worked. And we need to use it to build the class hierarchies, right? How do we do that? Okay, so we have we have classes. 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 Let's see what's in there. Base classes. Huh. Okay, so we're looking at this one here. Base classes. Do we know any properties about inheritance? Mutual inheritance, public, protected, private? There's this flag thingy here. Offset flags. Offset flags masks. Virtual mask, public mask. What? Okay, I have no clue what that means. Diamond shape mask. What? Has base class objects with 2 or more derived objects. Huh? I don't understand. Base is public. Base class type info. Base class type info. Offset flags. Okay, how about we copy this one here? Base class type info. Dynamic cast info. Okay, let's put a VMI typeinfo base info offset flags. Okay, let's put here if those flags are not 0, then let's put a breakpoint here. Oh, int a 0. Why is this failing? There we go. Put a breakpoint here. Okay, so that is 2. 2. 2 stands for basis public mask. Oh, what is that? 10242. Oh. Well. Huh, what is that? Is virtual. The fuck is that? The hell? I have no idea what's going on here. Search below. What does that do? What? Search above destination. Search below destination. I don't get it. Non-virtual public base class. Non-virtual public base class. So this offset shift, what does it do? 8. Huh? So we have this value here. Okay. And we shift it. We shift it by 8. Then what? 40. 40. What does that say? Hex 28. I don't get it. Public mask, what is that? Huh. Offset flags. Virtual mask. Okay, apparently it's also... Huh? The fuck, yeah. The search functions for base class type info are simply convenience functions for adjusting the current pointer and parse below as the search is passed up to the base class node. I have no clue what this just said. What is this bullshit? This is all aliens speak to me here. What is this saying? This is remarkable. It really is remarkable. What? Okay, so what do I do with this? Base is public. And if that is not set, what does that mean then? Base is private? Base is protected? What is it then? Okay, let's ask ChatGPT here. Can you explain the base class type, the base class type info struct? It is taken from LLVM in private typeinfo.h. Used for runtime type identification, RTTI, okay. In C++, it represents information about a single base class in a class hierarchy and is primarily used for dynamic casting operations. Okay, let's break it down. Base type, a pointer to the RTTI of the base class. Offset flags contains information about the base class, such as its visibility. Public or private? Whether it's a virtual base and the offset to the base within the derived object. The offset. Whether it's a virtual base? And the offset to the base. The offset to the base. Okay. If set the base class is virtual, okay. If set the base class is inherited publicly, okay. Indicates that the offset to the base class is stored with a left shift of 8 bits. Base offset. Okay. Okay, I think I understand it now. I see. Okay, then how about we say here, we break it down to a bit simpler base class. We save it as Boolean is virtual. 1. Virtual inheritance. Bool is public. Public inheritance. Private otherwise. And the offset, base offset. We simply do uint 32t base offset. Well, it's a bit large, isn't it? Let's go with 16. I think that's good enough. Base offset in bytes. Okay. Okay, we don't care about these, I guess. So if public mask is not set, then it is a private. Then it is a private inheritance. What about a protected inheritance? Inheritance. Yes, it's not set. Then base class is not inherited publicly. However, this does not necessarily mean the inheritance is private. Could also be protected. Oh. Could be either protected or private. Aha, okay. Okay, so we won't know if it's private or protected. Okay, so we say public inheritance, private or protected. Protected otherwise. Okay. Okay. Okay, how about we copy this here as well? How about we rename this as well to VMI? Base SI. Man, this is slow here. How? Class type info. Okay, let's ask here with SI class type info, can we also get any information about public or virtual inheritance? No, does not store any. Okay. Unlike it does not have offset flag, has a single base, but not how it was inherited. The only way to get at this information is by looking at the full RTTI structure. Yeah. If a class has a single virtual base, SI class will not be used. Aha, will instead use it. Okay, I see. Single private inheritance. There's no indication of private inheritance. Okay, so if is used, what should I assume, public or private inheritance? What makes more sense? You cannot assume. If you must make an assumption, private inheritance is the safer default. Default inheritance mode. Public, private. Okay. Well, what we can do is, if we don't have information, then we say is virtual, is public. Public. Okay, how about we say enum base class visibility then we put a uint 8 t, we put unknown, we put private or public, private or protected and public. Okay. Then we say here this visibility. Okay. Is virtual. Say false. Unknown. Okay. We call it private or protected. Let's say single base single base class will provide no information about visibility. Public. Private or protected. Okay, I think that makes sense. Okay. So here we would say, where are we? Here, so we would have base class. Here, base class. And we say base class dot is virtual is that and man, I hope one day I will be healthy again. Would be great. I was sick so long now. End of December, January. It's pretty bad. It's really bad. Okay, so we have this, and we say virtual mask, right? Okay, so this is virtual. And we say we say visibility public mask base class visibility public, otherwise we know it is private or protected, right? Okay. And then let's fix the order. Base class dot base offset how about we put a new UN32T offset flags equals this one. Make a copy of it. Const. I save a bit of typing here. Okay, offset flags, and then we go with this. Offset shift. All right. How about we put this here, UN32T base offset I put that here, and we put a assert base offset is smaller than 0x FFFF. Okay. You let's do a static cast. UN 16T. Okay. Because I suspect that this is large enough. Okay, let's see how that looks. Okay. So base offset 0, public, not virtual. Let's see some other examples. Base offset 40, public, 0, 40, public, 0, 20, public, okay. Public, 4, public, false. This is interesting information. It means that we know how large some of the classes are, right? Yeah. Yeah, it's interesting information. Yeah. Can we... base class... I wonder if there's any ever virtual inheritance. Virtual inheritance is really unlikely. Let me see. Let's put a breakpoint here. We say condition base class is virtual. Let's see if that ever hits. No, it doesn't. Yeah. I've never seen virtual inheritance actually use. Yeah. It's one of these things that is there, but like, why would you use it? Yeah, I don't know. Okay, but this is interesting. Now, I think we could also use this information about how big a class is. Yeah. So if we are base count, we say if, hold on. If I smaller than this minus 1, no, yes, then we can say parent name base class how about we call this base name, then base name how about we call this here base class size. UN16T let's call it size. Let's do a 0, and then here we say base class equals that base class size. Okay. Okay, let's put a breakpoint here. See how that looks. Okay, I plus 1 I plus 1, there we go. Actually, this is not correct. We need to this minus this minus this. Let's type in a plus 0. Let's see, base count 2. I 0 plus 1, okay. And so the size is 40. Yeah. Okay. Okay, let's look at some more samples. 40, 0. 40, 0. 20, 0. 4, 0. 20, 0. Makes sense. 16. Okay, cool. So we can get some sizes. Yeah. I don't know if there's any other ways to get struct sizes. But this is a nice thing. Yeah, okay, that's not bad. I mean, we take any information we can get. Let me put a comment here. For what it's worth, we can get some class size information from the inheritance base class offsets. So we can generate static asserts for some classes and populate them with dummy members producing the size. Okay, that's not bad. For this one, we can't do it, I think. Yeah, it doesn't have this. Yeah. Yeah, base class size. Okay. Then, okay, so we should have all the data now. So this one will produce. This one will produce base type. Let's put this here, base class. And I think this one will just be defaults, right? Yeah, unknown, 0, yeah. Yeah. Okay, so what we're probably looking at is name to class index, name to enum index. Okay, so we're looking at index t find or create enum by name, std string name. Okay. Find or create class by name. What if we have a class that has a name and that is present in 2 different namespaces? Well, I don't know. Then we are screwed. Huh. I don't know. I don't know. Well, let's just roll with it for now. Find or create enum by name. Okay, let's copy this garbage here. Then we say name to enum index. I put here enum type enums okay. Now I do the same for class. Name to class index. Say class type, classes, I think we can remove this assert here because it's already guarded by this one here. So this will always be true, right? So I think we can remove this. Yeah. Okay. Okay, and then here we put find or create class by name. Class name here. Okay. And then here we do a find or create enum by name, right? And then here we do the same. Find or create class by name. And then base name. Here we do index t class index. And then here we do index t base class index. Yeah. And then we do classes class index dot base classes dot pushback base class index. Yeah. No? Somehow it's complaining. Why? I don't know why. Oh, right. Base class dot class index. There we go. Let's put this here, here, and this base class goes in here. There we go. Maybe put a mplace back std move, which doesn't make much difference, but actually it should be pushed back. There we go. Okay. Then here we do here we have base class, base name, base class size. Classes. Here, let's put a uint16t size of this class. Okay. Okay, and then we take this here. No, this. This. Base class, how about we move this down here? Let's stop debugging. Let's make this const as well. Let's put this here. Okay, and then we do pushback base class, and also we put msize to base class size, base class index, msize to this. Let's put a assert this is equals 0 or this equals base class size. How about we do class self. How about we call it main class? Main class. And then we do base class main class, base classes. Let's move this up here. Okay, let's see. Class name. Base class. Okay. So okay, that is unexpected now. Why is this 0? Overridable 0. Okay. 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 Fair. Memory pool objects. Already found. Okay. Let's remove this. Okay. C sample sound 3D. Main class. Size. Okay, the size looks weird. The size. Because we don't have it initialized. Let's initialize to 0. Yeah. Let's restart. Okay. Okay. M size 0. To base name C3D objects. Flags 2. Visibility public, yeah. And this one size is 40. Okay. Base name is 3D objects. Okay. Size 0. Okay. Base class is base class. Oh, we got a crash. Uh-oh. How did that happen? Oh. Huh. Main class. Oh, I see. Yeah. Right. That's not safe here. Okay, so we have to put this here. Put this away. How about we do index t base class index. Base class index. And then we put this here. And then we put this here and there and there. Okay, and then here we rename this to main class index. There we go. I guess that works. I think we can make this const. Let's rename this to main class index. Main class. Okay. Okay, that should work. Oh boy. Okay, let's see if that assert never hits. 0, 40. Okay. Base class. All right. Let's see. Okay. Error code. All right, save code. Oh, we got hit here. Oh, it does hit. Huh. Okay. $16. Ah, okay. I see. Then we say this equals 0 or this equals 0. These are identical. Yeah. Okay, let's try this again. Okay, there are only 3 enums. Okay, but this works through now. That's good. Okay. Okay, so we have classes now. Yeah. Okay. Good. The next session, I would say, we need to start create the relationships between the classes and the functions, I guess. Yeah. What else is in there? Yeah. Well, functions inside this class. Yeah. Yeah. There's more relationships to build here. Yeah. Okay, but it's already not too bad. Yeah. Okay. I'm making baby steps here. No. It's better than nothing. All right. I'll take a break here. I wish you a great day or night. Until next time. Goodbye.